Hello, everyone. Let's solve the Leetcode problem number of islands. It's Leetcode number 200. Let's read the problem. So given an M cross N 2D binary grid, which represents a map of ones and zeros, ones being the land and zero being water, return the number of islands. So basically, you have some sort of grid like this, and these grids have numbers, ones and zeros. So ones represent the island, zeros represent water. Now, your job is to figure out how many islands are there. Now, but just by the look of it, you can make out, and let me read it out. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So basically, any one that is represented as part of the grid is an island, as long as the adjacent one is either vertical, like let's say for this is vertical or this is horizontal. So so this element will only be part of the island if it is uh, horizontally connected to another part of the island, right? So if you think about it, just by the look of it, you can see this whole thing is basically one island, right? This whole piece is one island. So that's what you want to find out. So for by the look of it, see, this basically is one island, and this one is not part of the island, even though they seem connected diagonally. The definition of an island here, as per the definition here, is horizontal or vertical. You have to be connected horizontally or vertically. And if you're connected in the diagonal, it's not counted. It's not counted as part of the island. So these are three separate islands. This is not one island, right? So because these are three separate islands, because there is no ones connected. So for example, the one here, there is no, all the ones are zeros. So obviously there are three islands in the second example. Now, the key thing to understand is this is solved as a graph problem. The reason it's a graph problem is because you're looking at each one of the nodes, each one of the ones is considered a node, and you're trying to find out another one which is connected is sort of like the edge connecting two nodes, right? The edge connecting two nodes. You're basically trying to find out how many connected edges are there, and you want to be able to count them, right? So that's why this becomes a graph problem. And some of the graph problems, you have to basically make the graph yourself. In this particular case, the graph is already given. So the graph is given as some sort of a grid, and your job is to figure out and some by mechanism by which you can figure out the number of islands. So in this particular example, this is basically the number of grids. As you can see, that this grid is arranged in the form of rows and arrows, rows and columns. M are the rows and N are the columns. Now, every time you traverse through this grid, you will need to figure out if it is a 0 or 1. If it is a 1, this is part of the island. Now then you immediately do DFS, depth first search, right? This is our algorithm that we've been solving of late. So depth first search, so you look for immediate neighbors. First search, so you look for immediate neighbors. And as soon as you find immediate neighbors, you basically record them as part of the island, right? This becomes one island. Now, and then you traverse through the entire array. So another thing you want to make sure is, in the previous case, in some of the problems that we have solved, we used to have some sort of a hash set, which used to store let's say the connected, which used to store the connected nodes. Now, in this particular case, we don't have, instead of doing a hash set, what we can do is we can, every time we count something as part of a connected graph, we turn that into a zero. We turn that into a zero. We encounter this. This is one. You turn that into zero. You encounter this. You turn that into zero. You encounter this. You turn that into zero. You encounter this. You turn that into zero. So basically, if we go back, you're basically turning, every time you encounter an island, you turn that into a zero, so that you don't get stuck in a infinite loop here, going back and forth one on one here, right? Every time you encounter a one, turn it into zero, so that you only need to traverse once. And you do the same. Through you go through the grid and you encounter another island, you turn that into zero. And then you see another, let's say, a couple of islands, you turn them into zero. The reason you have to turn them into zero is to ensure that you don't double count them, and you don't have to traverse the entire field again. So every time you encounter three islands, and you increment this number of islands variable, so that eventually this becomes three, and you turn them. You turn these number of, every time you encounter one, which represents the island, you turn that into zero. The time, and let's talk about the time complexity, right? Of the time complexity of this problem is essentially O of m cross n. That's due to the fact that you traverse through the entire grid, and every time you encounter islands, you turn them into zero, and you don't go back again. So even the space complexity is O of m cross n, because like, even though you're employing recursive DFS, so wherein, like, every time you encounter an island, you do a DFS around the neighbors of the island, but you don't, and immediately once you do the DFS of the neighborhood, you immediately turn them into the ocean, which is zero. That ensures that you don't have to traverse back into this grid ever again, right? That ensures that space complexity is O of m cross n. The idea being, every time you encounter an island, you do a DFS of your nearby neighbors, and then every time while you do that, you turn them into zero, so to ensure that you don't get stuck in an infinite loop between two two of the islands. And the space complexity is O of m cross n. So we are basically coding a number of islands. So this is the input grid. We import a statement, full list. So this is a string, and we return an integer. So first thing we do is we take the dimension of this grid. Right, and then we're doing it through depth first search algorithm. Okay, so we sort of will come back to this. Before, we'll figure out how we will use depth first search algorithm. So let's suppose we have the whole idea here is we're counting the number of islands. You declare a new variable and then call it island, and then since we have taken m is the number of rows of the grid that we have declared already, which is stored here, right? This gets stored in m, and that's what we're calling here. And we basically go into a for loop and basically ask if this grid entry matches with so this is all string, so we have to basically compare compare strings. So then if we encounter number of islands, then what do? We count them as one of the island, and then we have a recursive structure wherein we call this DFS again, right? Now, how do we, what is the main logic is, first we figured out we are basically using DFS, and then we use number of islands as a variable, and then we went into the grid, understood when the grid entry is equal to 1, and every time we encounter it to be 1, with the help of DFS we were able to count that as number of islands. And what is inside DFS? We basically look at the boundary cases where you don't want the grid to go out of the bar, out of the limit. The limit is set by the dimension which we got here. We can even comment dimension of the grid, and then j is less than 0 or j greater than equal to n, or, and what are we checking here? The main thing that we are checking is the corner case that is not equal to 1, right? We want it to be equal to 1. If it is not equal to 1, we just return. Else, first thing we do, as soon as let's suppose we did encounter 1. So we did encounter 1. So what do we do? Oh, first thing we do, we did encounter 1, so you convert that into 0. Okay. Then you take the DFS by, this is like basically write check DFS this is bottom check DFS. This is basically left check. So we're looking at DFS not going outside the boundary. Right. And then if we get all of this, we basically say return num. Right. Now this should work. Now for this, in order for this to work, you got to initiate this function, because we are not writing it in Leetcode platform. We're writing it in VS Code. You're doing a constructor. We initiate. We need some way by which you can call this function, right? And another thing you can do is initiate it with respect to some variable and then print it, so you get the output that you can see. This is fine. So it's basically giving the answer as 3, which is the right answer, right? You can see here, this is one island, this is another island, and this is the third island, right? So let's suppose we make it into 0 and then run it again. You're getting the answer 2.